Hello, I am Cosmas Cosmopoulos and we're going to discuss about simple data types and operations in Python. So in this session, you will learn the simple data types of Python and you will experiment with arithmetic operators and with string operations. Let's start with the simple data types of the language. We talked a little bit about variables in the past. In mathematics, problems, quantities are referred to by names. Names are given to values and these are called variables. So here there's a simple program in Python that calculates the distance. If you have the speed, we assign the value 50 to the speed, the value 14 to the time elapsed variable, then we say that the distance variable is equal with the speed times the time elapsed, and then we print it. So we have a very basic calculation of the distance and prints here 700. So the first three statements here are assignment statements. We have said that we use the equal sign as the assignment operator. Pretty much it assigns a value to a variable. On the third assignment statement here, we have an expression that is evaluated. So firstly, the computation happens here between the speed and the time elapsed, and then the result is stored in the variable distance. How do we name variables? Can we do whatever we like? Well, a variable name needs to be a non-empty sequence of characters of any length, with the start character to be an underscore or a capital or lowercase letter. So pretty much it needs to start with a letter or an underscore. And the keywords of Python are not allowed within the identifier names as identifier names. So here are the most common keywords of the language. You can't use these only as identifier names. They can be part of a name, but it cannot be a name by itself. Now, in terms of data types, we can have numbers and strings. Numbers are referred to as numeric literals, and characters are referred to as string literals. We have two types of numbers. We have integers, ints, and floating point numbers, floats. Whole number written without a decimal point is called an integer. A number written with a decimal point is called a float. So you can see here the numeric data types. If you use the built-in function type, you say print the type of 1, you will see class int. And if I say print the type of 1.0, you will see class float. Print the type of 1 within quotation marks, you will see class string. So if I go here very briefly and say type brackets of 1.0, you will, and if I print it, let me delete this hello world. If I run this one, say class float. But if I put here the number within quotation marks, then immediately it becomes class string. So you can see here some examples of different data types. A sequence of characters that are treated as a single item is a string. As a sequence of characters, they need to be surrounded by either a single or a double quote. Pretty much doesn't matter whether you're going to use a single quote or a double quote as far as you are consistent. So the opening and the closing quotation marks must be of the same type. String variables can also be, variables can also be assigned to string values. They created, meaning they come to existence, the first time they appear in the assignment statements. And they can be used as an argument of a print statement. Of course, as an argument of the print statement, the quotation marks are not included in the display. Variables have a scope. Every variable has a scope. A scope means where this variable is valid, or if you prefer, for how long this variable resides in memory, from what starting point up to which ending point does this memory location hold a particular value. So, for example, if I define variable a in program A, if I try to use it in program B, even if it is in the same project in PyCharm, this will be wrong. Why? Because the variable will be out of scope. The basic scope of a variable is the program in which it has been defined, starting from the point is defined onwards. Of course, when we learn about functions, we will see that the variable has a scope of the function. But in general now, and to make it easy, we can understand that if we declare a variable outside our program in another program, even within the same project, this variable will not be accessible. Now, where are the variables stored? Every variable has an address in memory. You can imagine the computer memory as a series of containers, each one being 1 byte in size, linearly arranged and numbered from 0 up to your memory size. So if you have 16 gigabytes of memory, the first byte will be byte 0, the last byte will be byte 16 billion something. Let's not go into that detail right now. So every variable has an address in memory. This address in memory is actually the byte or the series of bytes, better, because 1 byte is not enough, the series of bytes that this variable is stored to. We can identify the actual memory location that the variable is stored if I use the built-in function id. So the id will give me the actual memory location of the variable. I'm going to use a tool called Python Tutor, a website, which I'm going to use frequently to show you how the memory is actually organized. And of course, this can help us simplify some of the execution principles. So if I go to the Python Tutor website and I put this code here, you see my variable a value, blah, blah, blah. If I click on Visualize Execution, first of all, it tells me if I have any mistakes, and we need to be careful because sometimes the quotation marks, when we transfer it between computers and the web, it might be different. So now I can go here on the left that you see on your screen, and I can run one by one the statements. So if I click Next here, what's going to do is it's going to define a variable in the global frame named my variable with the content of a value. And then I'm saying print the address in memory is, and then I get id my variable. And you see here it has a very big address. I mean, this is a server, so it has much memory. But this is in particular the byte in memory where my variable, or the series of bytes in memory, but this is the starting one, where my variable is actually stored. If I go, and be careful because this is fundamentally different from any other programming language that you have used in the past. So if I go and I say, with the same name, I'm going to put a different content in my variable. Yeah, it doesn't change anything the way that we view it. We say we have the same name but a different content on that. If I go and print the memory address is different. Why it is different? Because in Python, every time you assign a value to a variable, it effectively redeclares that variable. So it effectively goes to memory, say, scrap what you had there and give me another different memory location to store the new variable. So every time we put some content into our variable, this variable is being redefined. This is very useful, and this is one of the reasons that the strong dynamic typing works very nicely in Python, because if I go and redefine my variable as a string, effectively it will go and use a different memory location to store that particular variable. So that is what happens. If I say n is equal to 5, after n is 5 is executed, the variable n is 5. But if I say n is 7, then it goes to another memory location, store 7. Very important, keep that in mind, because later on we will see why this makes our lives easier sometimes and more difficult others. Remember, the expression on the right of the assignment statement is evaluated before the assignment is made. So in Python, this allows us to create augmented assignment or compound assignment operators. What does this mean? I know that if you see this in maths, you will say it's a crazy statement, but the equal sign, it's not for equality the same way it is in maths. The equal sign here means compute the value to the right and assign it on the variable on the left. So look what var1 is. Let's say var1 is 5, okay. var1 is 5, plus 1 it becomes 6. Store it back in var1. In order to make our lives easier, and because programmers tend to be efficient, and we don't want to type var and var and var again, or the name of the variable, the name of identifier multiple times, what we are doing is we are using plus equal. Plus equal sign, like the one that you see here, is exactly equivalent to this one here. And there's absolutely no difference. And I know that at the beginning you're going to say, oh, well, I prefer this one, it's more clear to me. But as you go along, you're going to see that the second one is much more efficient. And you're going to use it many more times. By the way, this doesn't operate only with a plus sign. It operates with all the arithmetic operators, as you're going to see them later. So with a minus, divide, multiply, and all the other operators that we're going to see in the next few slides. You probably have noticed by now, and you saw that with the type and the ID functions that we have already used, but together with the print as well, that Python has a couple of built-in functions. Let's talk about some of them. First of all, the print function. We used it a couple of times until now. We use it to display numbers on the monitor, on the command line terminal, we will call it. If n is a number, print n will display the number n. The print function can display the result of evaluated expressions. So a single print function can display also several values. Look at this program here. If I say print 3 plus 2, it will print 5, comma 3 minus 2, it will print 1, comma 3 times 2, it will print 6. All of them in one single line, because the print function by default, when it finishes, it gets you the new line. We can change that, as we're going to see later on, but this is not of our primary interest right now. Same thing happens with the second one. And I know some of you are going to say, what is double multiplication sign? Well, I do have all the operators later on, but to cut the long story short, this is the exponentation operator that Python supports. That is why 8 in the power of 2 is 64, as you see it here on the result. Python has also an input function. So if I say my name equals input, the input function waits for the user to type some text on the keyboard and press enter. Now, the important bit here to remember is that we will type some text. So even if I put a number, it will be treated as text, because the keyboard inputs text, not numbers. So if we would like to treat it as a number, we need to convert it, or better, we need to parse it to a number. And we'll see how this happens in a minute. So the input, output, print, and input. And we have already seen type and ID for introspection. There are two more, dir and help. I will show you this later. It helps you get some sort of insights on how to use functions. And we have these three functions here that you see, which I will pay more attention right now. Int, float, and str, string. These are conversion types. So you input a number and you store it to my var. But this number is a string, which means you cannot add, multiply, or divide another number. If you want to be able to do that, you need to convert this to an integer or to a float. In order to do this, you need to use the int function or the float function. Have a quick look on this example. If I say here, my var is equal with input, and I say, I can put here a text, enter a value, and then I print my var. This is absolutely fine, but even if I put a number, this will be a string. So I enter a value, 10.12, and I print 10.12. But if I go here and say result is equal with my var multiplied by 1.12, for example, and then say print the result, you will see that here I will get an error. Why? Because what I have inputted is going to be text. And say I cannot multiply a sequence of non-integers with type float, because this is text. So if I want to convert it, I need to say, look, convert to a float. That's why we say it's conversion function. Whatever is inputted. So whatever is inputted with the input function here, of course it needs to be numerical to work, you need to convert that to a float. So if I run this now, and I say 10.1, it converts to a float and outputs it. No problem. I can convert also to an integer if I want to, or I can take a number and convert it back to a string if there is a reason to. We're going to see that sometimes there is a reason to do so. So we have three functions for conversions: int, float, and string. We will convert a string to an integer or a number to an integer. It will convert a string to a float or a number to a float. And the str will convert a number to a string. By the way, if you want to find all the functions of the language, you can go online to python.org and have a look at the library of functions. The link is provided on this slide. So look here what happens. If I have an integer expression, a numerical expression, 2.7, and I use the int function, it will convert to 2. Carefully, it doesn't round. It doesn't round. What it does is, it converts it to an integer, which means it gets rid of the decimal part. If I want to round, because you probably saw in my previous example that it had many decimal digits, if I want to round, I can use the round function. If I use the round function without any argument here, it rounds to an integer. But if I say comma 2, it will round to 2 decimal digits. Or comma 1, it will round to 1 decimal digit, and so on and so forth. So if I go back to my previous example here, and I say print round result, comma 2, it will round it to 2 decimal digits. So if I say here 10.1 as I did before, you will see the result will be 11.31. I'm continuing, but you have the ability to pause the video anytime and copy the examples that I'm doing at your own pace. We also have the ABS function. Some of you probably can already guess. This will give me the absolute value. So if it's a negative, it will make it positive. Straightforward. Here you can see a brief example program that evaluates functions and prints the results. So I have A2, B3, and said give you the absolute of. You can do a calculation there without a problem. You will get 11. Convert to an integer the result of a to the power of b plus 0.8. So you will still get 8 because the 0.8 will be ignored. And round this to 3 decimal points. Here you can see a very basic example. This example here is the area of a squared room. So let's say that we would like the length and the width to be dynamic variables. We use variables for length, width, and area. We're going to use the input function for taking the values from the user. We're going to convert the input received into a number with the function float. The multiply operator is the asterisk in Python and in all programming languages. And the formula for computing the area is length times width. And I'm going to use the print function to display the result. And here you can see the simple example. You see I'm using float to convert the input into a floating point. I'm calculating the area as being the length times the width. And then I'm printing the result. The only new thing that you see here is this character here, the escape character, the backslash. This is not required, but this helps me if I want to write on multiple lines. Because, for example, in this PowerPoint slide, if I was continuing with this comma area, I wouldn't be able to fit on the slide. And obviously, when you're using your interpreter, you might not be able to fit something in a line, and it's not nice to scroll. So what you're doing is you put the escape character, the backslash, and this allows you to go to the next line and write. In principle, if you break anything within quotation marks, a string, it's not a problem. But if you don't, then you need to use it. So this is what this backslash character is doing. You can test it on your interpreters at your own time. Third topic for this session is arithmetic operations. Well, I have shown you many, but these are the arithmetic operators that we can use. We have the addition, subtraction, multiplication, float, division, classic, and then we have 3 extra operators that I would like to make more clear to you. We have the 2 division signs, and the 2 division signs are performing what we call integer division. So they divide 2 numbers and give me the integer result. So if I divide, let's say 20 by 3, I will get 6. Because I divide them as 6 point something, but I will not get the point something and will not round. So I'll get 6. If I divide 1 by 2, I'll get 0. The 2 asterisks are used as the exponentation operator. So 4 in the power of 0.5, just going back and reminding you quickly maths, this means the square root of 4. So the result is 2. So with the exponentation operator, we can do square roots, cube roots, and other things if we want to. And of course, we have the remainder operator or the modulo operator, which is performing an integer division and returns back the remainder. So here, 20 modulus 3, it will perform an integer division of 20 by 3, the result will be 6. It doesn't show you 6, it shows you the remainder, so the remainder here will be 2. So the remainder, or the modulo, is very useful in programming. So if you want to find, for example, odd or even numbers, an even number modulus 2 is always 0, and an odd number modulus 2 is always 1. Also, if you want to do algorithms like the one we're going to do later on for checking the validity of a credit card, we use mod 10 to do that, if it divides by 10. If we want to do anything with calendars and we want to change the weeks every 7 days, we're going to do mod 7. So generally speaking, the modulo or remainder operator is very, very useful, and we're going to see why later on. The problem here with the arithmetic operators and converting them into computing is that it's very difficult to write, and it requires too much attention on the brackets. We might need more brackets. we might need to be more careful with the brackets. The first statement here, I suppose all of you can understand it. It doesn't matter whether we solve it or not, but we can understand it. If we write it in a computer language, it looks like this. And we need to be careful with the concept from left to right operations plus the brackets in order not to make a mistake. Also, look here, I'm also using this escaped character in order to be able to move my calculation to the next line. So this is not an operation, but is the escaped character to break a line for readability. Somebody will say, okay, does this mean that we can only have arithmetic operations? No. We can also have string operations. We can have concatenation of strings, for example. Let's say that I have 3 strings. I would like them to be joined together. I can use the plus sign. The plus sign allows me to join the 3 strings together. Carefully, it doesn't put any space anywhere. So, if I say here, first string is, it will print abra. Second string is, it will be kada. Third string is, it will print bra. But the concatenated strings, it will print abracadabra as one single word, because the plus sign here does not add any spaces on the string. So, except adding, concatenating, we can do other operations with the string. We say the string is a sequence of characters. If it's a sequence of characters, then the items of the sequence can be accessed through indices. So let's take the string abracadabra that I had before. If I say, I would like to access the first character of the string, the first character of the string would be the name of the string, my string variable, character 0. Careful, computers start counting from 0. So the first item is item 0. The second item is item 1, and so on and so forth. This also in the beginning can sound confusing. So my string variable 0 is the first character of the string. Position or index of a character in a string. Now we say here, the first item 0, the second item 1, the third item 2, and so on and so forth. So let's say that we get this expression, spam and eggs. This has, how many? Overall 11 characters. From 0 to 10. Careful, we always start with 0. Spaces also count. So, I can slice a string. I can take a portion of the string using indices. So if string 1 is a string, then string 1 square brackets m colon n is a substring beginning at the position m and ending at the position n minus 1, because the last one is never taken. Keep that in mind, because we're going to see that later on when we talk about ranges, iteration and other stuff. The last item is not taken. So here, if I say spam and eggs 2 column 7, it will start from character 2, which is the third character, A, and will go up to character 6, 7 minus 1. So if I say print spam and eggs square bracket 2 column 7, it will print space ampersand space, whatever is circled with the red circle here. Let's look at this as an example. Let's say that I have Python, okay, and I say print Python 1. It will take the first character, this one, character 1, because the character 0 is P, character 1 is character that will be outputted. Python 5, well, 0, 1, 2, 3, 4, 5 will be the letter N. 6 characters overall, character 5 is the last one. If I say print 2 column 4, it will start from character 2, P is 0, Y is 1, T is 2, and will go up to character 4 minus 1, i.e. character 3. So it will print T and H. Now, another thing that we can do with the strings is that we can find certain characters. So if I say str find W, and that's string 1, it will tell me that W is character 6. So 0, 1, 2, 3, 4, 5, 6. And if the character doesn't exist, like X, it will tell me it's not found. And I can use rfind to find it from the right, or reverse find if you like. Python also allows strings to be indexed by the position in regards to the right. The first character is character 0, the last character is whatever it is, the string. But if I want to start from the last, I can start from -1. -1 will give me the last character irrespective of the length of the string. -2 is 1 before the last, -3 is 2 before the last, and so on and so forth. So I can have negative indices as they appear here. So for the same thing, this is -1, -2, -3, -4. And look here how we can have an example with negative indices. So if I say Python -1, it will print N. Python -4, it will print T. Python -5, what does it mean? It means go -1, -2, -3, -4, -5. This is the starting character. So -5, -4, -3, it will not go to -2 because the last one is not taken. So it will print YTH. You can see similar examples with spam and eggs. Pay some attention here. If I say start from 0 and go to -1, we mean print the string in its whole totality. So print the whole string. Start from the first character and go up to the last one. Last one though not included. So this is a very easy way to get rid of the last character of a string all the time. Because -1 is not taken, yeah? Careful. Last one not taken. Also, look at the bounds. If I say print Python 2 column nothing, it will print until the end. If I say start from nothing and say column 4, it will start from the beginning and will go up to 4 -1. If I say column here, it will print everything. -3, colon nothing, it will start from -3 and go to the end. Nothing to -3, it will start from the beginning and will go to -3, -1, to -4. We saw in the abracadabra example before that two strings can be combined to form a new string. And this can be represented by the plus sign. We can have a combination of strings, plus signs, functions and methods to be evaluated together if we want to. But we need to be careful because the plus sign does not add any spaces. Any combination of strings, plus signs, functions together is called a string expression. I can also have string repetition and I can use the multiplication. If you think, multiplication is actually repeated addition. So if I say ha and I multiply it by 4, I get ha, 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 ha. So actually it's like adding it 4 times. Or I can do something like this here. I say take cha, multiply it by 2 and add something else. That's why I say a string expression. So you can multiply strings, meaning add several instances of the same string, or you can add, concatenate 2 or more strings. So in this session, we've learned about simple data types of Python. We experimented with arithmetic operations, and we experimented with string operations. This was a slightly longer session, but with this we conclude Unit 1. If you have any questions, please do not hesitate to ask.